Okay. All right. That's only there for my virtual students. I'm hoping to have a better way to do this eventually. Figure it out, okay? But my smartboard's still not working. For me to touch it, and my computer's messed up. So right now we're just having to wing it, okay? Which is fine. Now we're gonna go over this now. Let's go to this, okay? So at the top it says part of an algebraic expression are called terms. Okay? Like terms are terms that have the same variables raised to the same exponents. Constant terms are also like terms. To identify terms and like terms in an expression, first write an expression as a sum of its terms. Okay? So let's go to example number 1, and let's talk about what that means. Okay? We have A. Okay? Question A is 5 minus 3x, or negative 3x, plus 2x minus 1. Okay? We see that. Okay. Now it asks us to rewrite it as a sum of terms. Okay? So we want to find what our terms are first. Okay? Do we understand what a term is? Okay? So what's our first term in this equation? 5. What's our next one?
Negative 3x.
Negative 3x. Good, I was wondering if you were going to catch that. Okay? Now, yes, this is we think of it as a subtraction sign, but this goes with this number. Okay? This is connected. Right? So it would be negative 3x. What's our next term?
2x.
2x. And what's our last one?
Negative 1.
Negative 1. Remember, those will always go together with the number in front, behind, or the number that is, okay. The negative will go with the number behind it, okay, or the expression with the term behind it, okay. Now let's find the like terms with these. Which one? Okay, what are like terms? Kind of the same thing, okay, the same thing. So if I have a 5 and a 2, are those like terms? Yes. If I have a 3x and a 5x, are those like terms?
Yes.
If I have a 3x and a 5x squared, are those like terms?
Yes.
No. Okay? So what are my like terms in this expression, in this equation?
Negative 3x and 2x.
Okay. So my like terms are things that are similar, okay? So I have a 5 here and a negative 1. This has a negatives to it, but are these like terms?
Yes.
Yes. Okay, so our first like terms are 5 and negative 1. What's our second like terms? Negative 3x and 2x, okay? Now, listen, okay? If we have, I need more board space. If I have a 3x, okay, what is this exponent? What is it raised to? A 1. Okay, so there's an imaginary 1 right there. Okay, do we understand that? That's important to remember, okay? Because a lot of times we'll see 3x squared, which means it's twice, you know, you have to multiply it twice, okay? Which would be like 3x times 3x is what that would be, okay? But we don't really get into that much, okay? But if we have a 3x and there's nothing there, that means it's 3x to the 1 power. Okay, though we leave the 1 off because we don't need it, because we know if it's just an x, it's raised to the 1 power. Okay, can everyone see that? I moved that, now James will can see it. You can see it? Okay, so these are our like terms. Do we see why we got like terms here? Okay, so let's do, so I was really confused already. Okay, listen in. B says 5x squared plus x minus 4x plus 2x squared. What do we want to find first?
Terms.
Our terms, okay? What would our terms be in this equation? Or really not an expression.
5x squared.
Okay, 5x squared is 1.
X.
X.
Negative 4x.
or expression. It's not an equation, it's expression. Okay? We're just separating it to get terms. So that we know that this is its own term, this is its own term, this is its own term, and this is its own term. Okay? We're just separating those. Okay? Now, when we find like terms, we're finding ones that are similar. Similar in the negative. It doesn't have to be negative, not negative. Just a regular integer. Okay? So it could be negative, it could be positive. If they're like in those ways, if it's -5 and 5, those are like terms. Okay? Does that make sense? Okay? If I have an x, a 1x, a 4x, a 5x, those are like terms because what is the x raised to? The 1 power, okay? Anything that's x and raised to the 1 power would be like terms, okay? Which you don't have the 1 here, it's just usually x, okay? So if it's anything x to the 1 power, those are like terms. If I have an x squared, okay? If I have a 4x squared, a 7x squared, a -8x squared, those are all like terms because of the x squared. They're all similar, okay? They all have the same x squared, they all are raised to the same power. Okay, these can't be like terms because why? They can't be like terms because this is raised to the what power, and this is raised to the what power? Okay, we can't. Those aren't similar. They're not like terms.
Can't you solve them though? Like,
But we're in an expression. We're not in an equation right now. Okay. Now, so our like terms in this expression are what? Between 5x squared, x, -4x, and 2x squared, which ones are like terms?
5x squared.
5x squared and what?
2x squared.
And 2x squared. Because of y, the x squared, okay, they're similar, they go together. Okay, which will get to what you do once you figure out they're together. Now what are the other like terms?
X.
X and -4x, okay? Now, if this doesn't have a number in front of it, can it still be a like term to -4x? Because what is this actually saying it is? There's a 1 in front of it, which we really don't need there, okay? So that's why we just do x, because we know it's a 1, okay? Everyone understand that? Do we understand that when we have an x here, there's a 1 in front of it? Because when we go to add these together, we have to know that this is a 1. Make sense? Okay? I would suggest write these down as we go. They are in your book, but sometimes writing down also helps you remember it. Okay, so do we understand that? An algebraic expression is in simplest form when it has no like terms and no parentheses. To combine like terms and have variables, use the distributive property to add or subtract the coefficient, which we're going to go down to example 2 now. Okay, so we have 4x Woo. Okay. We got 4x minus 3/2 -2x plus 5. Okay. Now we're simplifying it. Now, does this have an equal sign? Is it equal to something? Okay, that means we can't get an answer for it. Like an actual one single answer. So if it would have an equal sign and a number, then we would try and solve for x, okay? But it doesn't have an equal sign. It wants it in, it says what? What's this word? Simplify, which means it wants it in the smallest possible way to get to it, okay? We're not going to find a specific answer. We're going to find this equation simplified, okay? So we talked about terms, okay? Now, what are our terms in this expression?
4x.
4x is a term. -3/2 is a term.
-2x.
-2x is a term. And +5 is a term. Okay, they're own separate terms. Okay. Now, what are our like terms in this expression? 4x and you're close. 4x and -4x. negative 2x, okay? Those are like terms, and what are other two like terms?
Negative 3 seconds and 5.
Okay, so then these two are like terms, okay? Even though this is an expression, or a fraction, this is still, can we still get a number out of this? Like a point, a decimal, anything like that, okay? This is still a like term to this, okay? Because there's no variable, and there's no exponent, okay? So this is going to be a like term to 5, okay? So these two go together, these two go together. Now, right here, this is rewriting this, which I'm going to rewrite this so that you can see it, okay? When we're talking about getting our terms, okay, this is how we would actually see this problem, okay? 4x plus a negative 3 over 2 plus negative 2x plus 5. Do we see that? This is so annoying. Okay, do we see that? Do we see why I put plus signs in between these?
Yes.
Because these negative signs, subtraction signs, go with these numbers. Okay? They're not just a subtraction there. They're really to be with them. So that means that there's actually a plus sign in between them. Okay? So we need to make sure we can see it as this is its own like term plus this own term, not like term, just this own term, plus this term, plus this term. Okay? We have to make sure we connect those negatives with those numbers or variables. Okay? If we don't, then our problem's gonna from the start gonna be wrong. Okay? We have to connect those with them. So if you need to write your expression out like this, so that you remember that that negative goes with this term, and this negative goes with this term, you need to write it out this way until you get the hang of it. Okay? And it's the same thing here, it's showing you how to do that. It's breaking it up. Okay? You're rewriting it as a sum, which is basically just saying, you know what, guys? Why didn't y'all say something to me? Oh, never mind. I'm right. I just saw it differently. Sorry. From this angle, it looked weird. Okay. So it's rewriting this just like I just did. Okay? Now, I would put a parentheses around this just so you know, but that's still the same thing. Okay? Now, we know our properties, right? A I can't say this word. Commutative property as addition, okay? Then our distributive property. Now, in this, what would we do to try and simplify this? So we talked about our terms. We got all our terms separated. What was the next thing I asked you guys to look for? A second ago, I wrote terms. And then what did I write? Like terms. So now we need to go find our like terms. Why do we need to find our like terms? So we can simplify them together, okay? So what are two of our like terms in this expression?
4x and negative 2x.
4x and negative 2x, okay? So what we're gonna do, what do we do with those? Okay. So say you have numbers, variables, exponents that are like terms, okay? When you have like terms, what do you do with them? And remember, we're trying to simplify it. Combine them, okay? Which means you would really add them together. Now, I say add them together, but really what might happen is you might have to, depending on what this gives you, will determine really what you do, okay? But we're gonna add these together, so we got 4x plus a negative 2x, okay? Now, do we know our negative and positives, okay? Do we know if we add a negative to a positive, do we know those, what's the word I'm looking for? Yes, Mo?
Same signs are positive, different signs are always negative.
Okay, so there's different things for multiplication, addition, subtraction, okay? So if I have a positive and then a negative, and I'm adding them together, what would I do here? Okay, I would subtract them, right? You have to have a positive and a negative. If I have a positive and a negative and adding them together, okay, I'm going to subtract them. Because it's really saying 4x minus 2x, really is what it's saying. Okay, do we know those, what's the word I'm thinking of? Rules. Do we know those rules when we add and subtract positives and negatives? Do we know those rules when we multiply and divide those negatives and positives? Do we know those?
Yeah. We had a song from last year.
You had a song for them last year? Okay, so if I was, okay, this is completely different. So if it was a negative 4x plus a negative 4x, what would we do here? This is not a multiplication, by the way.
You add those. You add those.
What did you say?
You change the negative to a positive. Wouldn't you?
Okay, so if I have a negative 4x minus a 4x, what would I do?
It would be negative 8x.
Okay, so we have same sign, and we're adding and subtracting, okay? You add the numbers, it'd be 8x, but then what would we do? I would keep the sign. Is that right? Yeah, that's right. That's right. Okay, makes sense? Now if I have one negative here, what would I do?
You would subtract.
Basically subtract them, which would actually be 0x, which is weird. Okay, so if I have a 5 here, let's say it's a 5 instead, or 6. Okay, I have a positive 6x plus a negative 4x. What would I do?
Subtract.
Really just subtract them, okay? And it would be what?
2x.
2x. Now what if I had a negative 6x plus 4x?
Change the 4x to a negative.
No, because that's just positive.
No, you change the 6x to x.
Okay? If we have one negative and one positive, we're still subtracting these together, okay? Which would get what?
2x.
2x, but which number is bigger?
Negative 6.
Negative 6. So what do we do with our negative? We keep the negative. Okay? Do we need to have a review on that probably soon? Maybe? Because I feel like, do you guys know how to multiply negatives and positives? I feel like those, we have a tic-tac-toe of that. I can show you the tic-tac-toe button for
We
you.
learned that last
The
time.
tic-tac-toe? Okay. The addition and subtraction can be difficult because you don't do it probably near as much as you would do positive or multiplication. Okay? I know 5 months is a long time, so we're trying to get refreshed.
I
Okay.
forgot what the tic-tac-toe was. It's
Yeah, you got it.
Things like that, where it's if you multiply, let's just not do that because we're not going to do it right now. Okay, we're not doing multiplication. We're not doing multiplication right now. Okay, so going back to this problem we have here. Okay, so we have our like terms is 4x plus negative 2x. So we're having to put these together. We're having to combine these. So we're adding a positive 4x with a negative 2x. What is this going to be? Like term wise. What are we simplifying this to? 4, okay, forget the variable for now. Okay? Because the variable is just going to go along with it. Okay? I need to figure out what 4 plus a negative 2 is.
2x.
2x. Okay? So if you have like terms in variables, forget the variables because they're just going to be added on at the end of the number. Okay? So if you want to go ahead here and say, okay, well I know my x is going to continue on because it's like terms, so I'm going to keep the variable. Now I got to figure out what my number is going to be in front of it. So then you'd say, what's 4 plus negative 2? What did we say it was?
2.
2. If this was a negative 4 and a positive 2, what would it be?
Negative 2x.
Negative 2x. Okay?
Yeah.
Okay. So whatever is the biggest number, positive or negative, what we keep. Make sense? Okay. So we got 2x here, okay? So scratch these. We got those out of the way. Got that out of the way. Now, what are our other two like terms?
Negative 3 over 2.
Negative 3 over 2
5.
plus 5. So now we have to put these together. I'm going to use a calculator. Sorry. Anybody tell me what they think this is without looking up here? Without looking in your book. Negative 3 over 2 plus 5.
3.5.
Okay, so you guys get to use, hey, listen. Okay, I'm going to try and get some new calculators ordered, but on these little cool fun calculators, there's a fraction button. You can put the fraction in the positive negative sign, and then add it. This changes the game. This is my favorite calculator right here. Right here. What is the number? 3 over 2 on the outside. The negative. Right here. Okay. Then you put what is it? Plus 5 equals negative over 2. Then you, hey, so I'll show you. If you ever need the actual fraction number, you can just like you can do this.
Oh my gosh.
Okay, so what I'm going to try and do is I really want to try and get calculators like this. Because this is a calculator I grew up on, and I love it. Okay, I love it. Okay? This is the one I really like to do. I got to try and get an order in to see if I can get it. This is your fraction, so you say negative 3 down over 2, and then move it out, plus 5 equals 7 over 2, and then you should have a button where it'll take it. Okay, then take it. Okay. I'm gonna take it back. Okay, so what did we say, Brandon, that this ended up being?
3.5.
7 over 2. Positive or negative? It was positive, okay? So plus 7 over 2. Okay, are these like terms?
No.
So this is as far as we can go? So this is our answer? Yes.
Or 3.5.
Okay. No, because this still, we have to break this down. These are like terms here.
Fractions, it's a decimals. 3.5.
Well, yes, we do not, right? But it doesn't matter, we can keep this as is. Okay. All right, let's do another one. We spent a lot of time on that one. Okay, let's do this one right here. Number 1. Okay. Actually, let's do this real quick. Look at here. Okay, look at this number 1 on your own. Okay. It says 5x plus 1 minus 2 plus 3x. What are my terms? 5x,
Negative 2.
1, negative 2, and 3x. Wish I could write on this. Because I can't. Okay, what are my like terms? 5x and 3x, 1 and negative 2. Okay? Ooh, okay, let's look at this one. 2y squared plus y minus 2y squared minus y. Okay? What are my terms in this?
2y squared.
2y squared,
Negative y squared.
y, negative y squared, negative y. No, I heard someone just say y. Remember that negative goes with it. Remember, if we have to do 2y squared plus y plus a negative y squared plus a negative y, that negative goes with that. Why? Because this actually, what if this is a number? That negative would still go with it, right? What if this is an x? Okay, it's the same thing. Any variable, hey listen, okay? Any variable that's different than x is still like x. Okay? So this would still be negative 1y, which would be just like negative 1x. Okay? They just use a different variable than x. Make sense? Okay? I confuse you?
Yeah.
Okay.
No.
So what are my terms here?
2y squared.
2y squared is. Okay, this is its own one. This is its own one. This is its own term. This is its own term. Okay? What are my like terms? 2y squared and what? And negative plus negative y squared. Okay? What's my other like terms?
Y and negative
Y plus a negative y.
But you can't prove it.
Okay? If we were to simplify this expression, what would this simplify to? Remember, this is a 1.
Y squared.
Okay, so we have positive and a negative. Subtract it. Take the sign of the bigger number, which is 2, which is positive, equals what? It's not equal.
Y squared.
Y squared. Okay? Now, what does this simplify to? We have a positive 1y and a negative 1y.
0.
Okay? You take a positive and a negative, you subtract them,
0.
so it would be 0y. Which you're not really supposed to simplify this one, but it'd be 0y. So then you have y squared plus 0y. Which I don't think that actually is anything.
Might just be y squared.
Okay? Alright, now let's go to number 4 here. Let's simplify this expression. Okay. We have 6r plus 2 minus 3r. Okay, we're trying to simplify this. So what are my terms?
6R.
6r,
2,
2, negative 3r. Okay? Those are our 3 terms. Now, what are my like terms? 6 and negative 3r. So if we're going to simplify this, what do we do? Tell me how to do it.
you would subtract 6.
Okay, so we talked about like terms. We have to simplify our like terms. Boys, if you're watching, pay attention. Okay? We have to simplify our like terms. So we already decided we have what? Like terms here and here, right? Okay, we have to simplify this. So we have 6r minus 3r. So we have a positive and a negative. What do we do? It's really just subtraction. So 6, what do we do? 6r minus 3r, which is, so 6r minus 3r is what? 3r, and what do we have left over? So we have this done, what do we have left?
2.
Plus 2. Is that simplified? Are there any like terms in this? Can I do 3r plus 2? Because this doesn't have what? Doesn't have a variable. Okay? So this would be simplified. Do we understand that? I hope you're taking notes, because if you have to go back and look at it, hope you know how to do it. Okay, let's do number 5. 2 minus s squared plus 3s squared minus 9. Okay? Is this a term? Is 2 a term? Is 2 a term?
Yes.
Yes, 2 is a term. Is negative s squared a term? Is positive 3s squared a term?
Yes.
Is negative 9 a term?
Yes.
What are my like terms in this expression?
2 and 9.
2 and negative 9. Make sure we continue to add that in there, okay? 2 and negative 9. And what else? Okay, negative s squared and positive 3s squared. Okay, so when we try and simplify this, we have to combine like terms. So what I would do, this is what I would do, okay? I would start at the left and say, okay, 2. What is my like term to 2? Negative 9. So what is 2 minus 9? So we have positive 2 and negative 9. What do we do? We subtract, which is what? 9 minus 2 is what? 7. Which one's greater than the other? Is 9 greater than 2?
Yes.
So what is 9's? Is it positive or negative?
Negative.
So it would subtract them. Whichever number is bigger, you take that positive or negative sign. Okay? So it'd be -7. So then I would say, okay, I'm done with that, done with that. Now I have two more like terms. So I have -1s squared plus 3s squared. What do I do?
You add.
I have one positive and one negative. So what am I going to do? I'm going to subtract them. What is right here in front of this? A 1. So what is 3 minus 1?
2.
2. Okay. Plus 2 what? Let me make sure that. What number was that? Number 5. Okay. Yes. Okay. 2s squared. You can, and here's the thing with math, you can write this either way. Okay, so you can write like this, or you can write it positive 2s squared minus 7. Okay, it's the same thing. Okay? Either way you do it. Right? We understand. Do we need to do one more like that? Do we understand that what you do is you first figure out, okay, these are separate terms, the negative goes with this, the negative goes with this one's positive. Then you say, okay, which ones are like terms? Then we need to simplify those like terms, okay? To where we get nothing that else can be simplified. Okay? Do we understand that? Okay. Okay, let's move to page 5. Okay, simplifying and evaluating an algebraic expression. All right. So now we're going to simplify -4 x squared plus 1 plus 3x squared. It says then evaluate the expression when x equals 1. Okay? Okay. So when we have this right here, what do we have to do? It's called the what property?
Distributed property.
The distributive property. When we have this right here, this number, by a parentheses in with something, we have to distribute this. Okay, the distributive. Sorry, I don't know why it's distribution. Distributive property. Okay. So how do we do this? Can y'all remember how to do this? Okay. So I have -4 here. I take it to this first expression in my parentheses. Okay, can everyone see that? Am I in the way? Okay, and I multiply this. So what is -4 times x squared? Okay, do you remember how to do this? Yes? You're like, this isn't the same like terms. What we do is we just multiply this. When we multiply this, it just adds on to it. So it would be -4x squared. Okay? You see how we did that? Do we see that we kind of added on this to it when we multiplied? When you multiply by an x squared, you just add that onto it. Okay? Now what will we distribute? -4 to what? 1. So we have -4 times 1. What's -4 times 1? So now is where we have our tic-tac-toe here. Positive, 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 negative, 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 negative. Okay? If we multiply a positive times a negative, we get a. If we multiply a negative times a negative, we get a. If we multiply a positive times a negative, we get a. If we multiply a negative times a negative, we get a. If we multiply a negative plus a positive, we get a. Okay? This is really handy to use if you ever need it. If you forget how to multiply a negative and a positive. Okay? This is really nice to have. Okay? So, we have a negative 4 times a positive 1. So what would it be? What's 4 times 1? 4. We said it's negative times a positive, which is a what? Negative. Okay? So now we have negative 4x squared plus a negative 4, or if you guys don't need this plus here, you can always just put negative 4. You just gotta make sure that that negative goes with that 4. Okay? Now what else do we have in this equation, or problem, expression? Plus 3x what? Squared. Okay? So now that we distributed, now we're at an expression that we just have been going over, right? We just did this, didn't we? So we have 4 sets of terms, right? We have a negative 4x squared, negative 4, and then 3x squared. Okay? Now, what do we do next? So we decided there are 3 terms. What do we got to figure out? We got to combine what? Like terms. Are there like terms in this expression?
Yes.
Okay, where?
Negative 4x squared.
Negative 4x squared and what?
3x squared.
3x squared. Okay, we have a negative 4 plus 3. Okay, so what do? We have a negative and a positive, and we're adding them. So we subtract them, and we get what? We get x. Okay, so we get 1. X squared. Which one's bigger than?
Negative.
What number is bigger? 4 or 3?
4.
4. Is it negative or positive?
Negative.
Negative x squared.
Plus.
Okay, plus or minus or subtract. What's left? We have this done, this done. What's left? Minus 4. Okay, are there like terms here?
No.
No, there's not. Is that right? Did I do that right? Yes, negative x squared minus 4. Okay, this is as far as we can go. So that would be our answer. Now, do you remember how to do the distributive property? So we understand this process. We have to first multiply. When you have this right beside a number, it's multiplication. This means multiplication. Okay? So then we multiply negative 4 to x squared. Let's do one more. Let's do number 7 right there on your own. I'm trying to give you enough time to do some of this work in class, but I don't know if I'm going to have enough time to do that. Okay, so let's not do that one. Let's do number 8. Plus 3 multiplied by x squared plus 1 minus 5. Okay, so what's the first thing we have to do here? We can't combine like terms yet, because why? We have to do the distributive property first, okay? So when you see this, what's the first thing you have to do? You have to distribute this 3 with this in parentheses. Okay, so we do what first? Multiply what? 3 times x squared. So what's 3 times x squared? 3x squared. Then we multiply what? 3 to the 1. We go to the next one. So what's 3 times 1?
3.
So we got plus 3. Okay? Now we can scratch that. Now what do we have? So then we just move these down. Okay? Now we have x squared plus 3x squared plus 3 minus negative 5. Okay? Is this what we've been working on right here? Yes. Whoops. Okay? Do we have like terms in this problem? Are we distributed? Are we good? Can we combine like terms now? Okay. Do we have like terms? Where? X squared and 3x squared. Okay. So what is this? We have 1x squared plus 3x squared. What would it be?
4x squared.
Okay. So we add 1 and 3. We just add the x. So we just add the x squared down. Then we would say 1 plus 3 is 4x squared. Okay. So then we can scratch those. Are these like terms? It's positive 3 and negative 5 like terms. Okay, what do? We have a positive 3 and a negative 5. What do? We subtract 5 by 3 is what? It's 2. Which one's bigger, 5 or 3? Is it negative or positive? Negative. Okay? Okay, so this would be, is this simplified? Are there any more like terms in this expression? Do we understand? Okay, let me make sure I got that right. I don't have a teacher's book only online, and I have to go over here and look and make sure that I have it right. simplified it and we got it down. But then what did it ask us up here too? Then evaluate the expression when x equals 1. So then right here, same thing here, then evaluate the expression when x equals -1. So then we would put, make sure I'm doing this right. We would put -1 in for x, okay? So whatever it's asking you to put x in for, you put that number in. So I would say 4 times -1 squared. Oops, that would actually be inside, wouldn't it? Okay, minus 2. So what is, this is a distributive property, isn't it? So what is 4 times -1 squared?
-4 squared.
-4 squared minus 2. Can this go any farther down?
Yes.
Is there any variable with it?
Square.
Is there a variable, which is like an x, y, z? A variable is a letter. Is there a letter left here?
No.
Okay, so what is -4 to the second power? You can do that in your calculators.
16.
Okay, we have, what does this mean? -4 times what? -4. We have negative and negative is positive. Okay, so what is 4 times 4?
16.
16. So it'd be 16 minus what? 2. So what's 16 minus 2? 14. Okay, so if it asks you to simplify the expression, this is simplified. Okay, but then it says then evaluate the expression when x equals -1. So then you would plug in -1 for x, and then you would actually get a number. Okay, we got that? Okay, let's move down to number 4 real quick. Okay, renting a room for a party costs $500. During the party, each guest receives a meal and a dessert. The meals are $15 per person, and the desserts are $6 per person. Write an expression in simplest form that represents the cost of the party. Interpret the expression. Okay? So if we have to write that in expression, what would we do? Tell me what your thoughts are. Okay, so look at the problem in your book or on the board. Okay, the words say the room is $500. Okay, so $500. Okay, now each meal is $15. Okay, so when it says each meal or each dessert, that is your x. That's your variable. Okay, because we don't know how many meals, we don't know how many desserts. Okay, so we have the meals are $15. So plus $15, but we don't know how many each meal. We don't know how many each meal we're going to be doing. So I said we have what, 18 in here, 17 in here. We don't know that there are going to be 17 of you eating lunch today. Okay, so that would be our x. Okay, now the desserts are what? $6, but we don't know how many are going to use it or are going to eat the dessert. So what do? An x. Okay. Do we see how we got that expression? Okay, so we have how much the room is costing. Okay, the meal is $15, but we don't really know how many is going to eat the meal, so we have to put an x there for the variable. Okay, the dessert is $6, but again we don't know how many is eating the dessert, so we put an x there. Okay, so this is the expression you would use. Then it goes down and says, at the bottom. Wait, where did it say that at? I knew it said somewhere.
Says what if each meal
Okay, what if, where's it say that at? Oh, at the bottom, on your own. What if each meal costs $20 and each person gets 2 desserts? That's not what I was thinking now. Oh, darn it. Okay. Here, one thing. I'm sorry. I was trying to give you time to do it in class, but I didn't get time to do it. So, homework. My binder is. Oh, okay. Homework. You have to do, and I want you to have it done by tomorrow, okay? And then we'll go over tomorrow in class. I want you to do problem page
I'll give it to you, Miss Miller.
Yeah, we could either do workbook page.
I just don't want to have to get Oh, my bad. You're fine.
I have something different for you guys. Come on in, Jacoby. I had that somewhere. Where I put that at?
There's a lot of pencil lead on the ground.
Whose phone is that?
I have no idea whose phone that is. Oh, this one?
Yes, that one.
Let me just.
Why is every?
No, that's Miss Jan's. Put that.
Okay.
That's Miss Jan's phone.
Why is it recording?
I have no idea.
Probably to check on the classroom.
Oh, it actually is.
It'll tell you, I don't know whose phone that is. And then, oh, Miss Jan's. Which one is it, people?
Miss Jan.
Okay, teacher.
We'll dance a videos.
My shoe.
I don't dance. I have my funny bone.
Your entire body is in phone.
Okay. Oh man, I forgot to hang out. Yes, if you have your